Hello guys, welcome back to lecture series on discrete mathematics. Guys, in our today's lecture we are going to learn Venn diagram and subsequent points. Okay, it is not only Venn diagram, union, intersection. Mostly we are going with the advanced concept from now onwards. Okay, basic we have learned in our previous lectures. So if you are interested to see these lectures, guys, go and check in my playlist. You will get the more lectures available there. Okay, so in my today's lecture, guys, I'm gonna explain to you all a Venn diagram. What actually the Venn diagram? Okay, what is actually meaning of Venn diagram? Mostly we often picturize, okay, mathematical concepts in mathematics. Okay, we try visualize or picturize the concept in mathematics. So to represent this picturized concept, we mostly use the Venn diagrams. Okay, that already I explained with the set of complex number, real number, rational number, okay, in some of the different shapes. Okay, so this one is called the Venn diagram. Okay, yes, whenever we have larger set, okay, in such a case we used to go for the Venn diagrams. Okay, what actually the meaning of Venn diagram? The relation between sets can be conveniently illustrated by certain diagrams. Okay, so illustration of the diagram by some of the properties, okay, that one we call the Venn diagram. Okay, under Venn diagram we denote universal set, okay, maybe larger set, subset of the sets, okay, proper set. This type of the set we denote in a Venn diagram. Okay, like for example I'm drawing the diagram here directly. Okay, so Venn diagram, like we denote this one as the Venn diagram. Okay, entire, so such a way you can take this one as the universal set U. Okay, so for drawing the Venn diagram you can use any type of the shape, not that necessary to use only square, rectangle. You can use the circle, okay, you can use any triangle. Okay, you can define the set, subset, visualize this one, you can add again this one. Okay, A, B, C, these three sets I consider here. A is a subset of a B, C is a subset of B, B is a subset of C, B is a subset of A, and all are the subset of a universal set. Okay, and they are the proper subset of U also. So easily you can visualize the set and its subset and their properties under Venn diagram. Okay, and this one is the universal sets. These are subsets and proper set that you can define. Okay, so if set A is, you can define A complement maybe outside. Okay, that one is very easy, guys, that we can union, intersection, that you can define here into the Venn diagrams. Okay, so we are not going for much detail, guys. Okay, so if you want to define disjoint set, okay, non-disjoint set, that way we needed a Venn diagram. Okay, that is only the Venn diagram. So we are not going in detail. We continue with the next operation on a sets. So in our next point we are going to learn operation on set. Okay, so operation on set means like addition, subtraction, multiplication. This kind of the operation we already learn. Okay, similar type of the operation we are taking, like union, intersection, difference, okay, and complement or many more operations, okay, that we are taking on a set. Okay, operation on set. Yes, so why we need the operation on a set? Maybe we can combine the element, or maybe we can identify the set. That is the reason we need the operation on a set. Okay, yes, so first operation we are taking, it is the union. This one is our first operation on a set. Okay, so what actually the meaning of union of sets? The meaning of union of a set means, consider the set. If I'm having set A and set B, be the two sets. Okay, union of these two sets, that means set of A and B, union for set A and B, we write A union B. Okay, is the set of all those elements which are either in a set A or in a set B or in a both sets. Okay, let me write set of element either in a set A or set B, in a set A or in a set B, or in a both set. Okay, that means A and B both are sets. Okay, so I'm having A and B both are sets. Okay, so sets of element either in a set A or set B or in a both set, that we call it as the union of a set A union B. Okay, that means we denote this one as U, capital union, as the like this bigger U. Okay, so we denote this one as A union B. Okay, A union B, we denote this set as the union of these two sets. Okay, and in mathematical form, like a set builder way, how we can write this one? Okay, so we are taking element A and B. Okay, like x element from A and B. Okay, x such that x belongs to A or x belongs to B. Okay, under curly braces. This is the way that we denote union of the two sets. Okay, okay, this one is the union of a two set. Let me draw with one of the figure, like a Venn diagram. I'll explain union of the set with a Venn diagram, guys. You need this one. This one is very important for defining the union of a set using visualized form. Okay, so if I consider universal set, this one is the U as the universal set. Okay, this one is the universal set. This one is the set A, this one is the set B. Okay, A, set B. So all the element under set A and all the element under set B called the union of the given set. Okay, so all the A union B is denoted as a dotted word. Okay, so all the part here, this one, again this one and this one, all the part we write it as the A union B. Okay, so this one is the union of the two sets. Okay, let me explain with one of the example, guys. Example can clear your concept easily. Okay, example first. If I consider set A, okay, 1 2 3 4, let me write 1 2 3 4. A set is this and B set is x y z. I consider two set 1 2 3 4 and x y z. So what is their union? A union B, 1 2 3 4 x y z. Okay, this one is the union for these two sets. Okay, so cardinality of A union B, what is the cardinality of A union B? Is the 4 and 3 7. Okay, this one is the union and their cardinality. I hope you all have understood, guys. Union, similar like we go for the intersection. Concepts are easy, just need to understand what actually their meaning is. Okay, yes, so we go for the next intersection. Intersection, we denote this one as the intersection. Okay, yes. Okay, what actually the meaning of intersection? Intersection of two sets. Okay, A and B, I consider the two set A and B, two sets. Okay, A and B are the two sets. Okay, all element of a set A, okay, and the set B we consider here for their intersection. So the meaning for intersection, that means I consider here set A and set B be the two set. Okay, set of all element in A, important word here, intersection means and. Okay, set of all element in A from A and set of all element from B, we write it as the intersection of the set A and B. Okay, and for the union, set of all element from B and set of all element from A. Okay, that means OR is the mostly important here. Union means OR, intersection means AND. Okay, these are the word we are taking here. Okay, and this one written as intersection between two set, we write A intersection B. We write this one as A intersection B. And in mathematical set builder form, we write x such that x belongs to A and x belongs to B. That means x should be the part of A and x should be the part of B. Okay, then we take as their intersection. Okay, yes. So let me draw with one Venn diagram so that you can conceptualize the or visualize concept easily. Okay, this is the universal set U. Okay, this is the set A, this is the set B, this is the set A, this is the set B. So here middle part between A and B, we consider the A intersection B. Okay, the element which is from A and the element which is from B, whenever both are common, we take this one as the intersection. Okay, so for example we take the some numerical example. Example 1, so we consider A as a 1 2 3 and B as the set 1 A B 2. Okay, this is the set A, this is the set B. A intersection B, that means the element which present in A and the element which present in a set B. Okay, what are the element both are present here? 1 and 2, 1 and 2. So common elements are 1 and 2. Okay, so their intersection should be 1 and 2 only, and the cardinality of A intersection B is equal to 2. That means number of element which is present here. Okay, so this is the intersection. Okay, yes. And we know that if you take the phi as the element, so phi it is always the part of every set, so that intersection can take phi element also. Okay, yes. We continue with the next point, disjoint set. Okay, third property, third type or operation, disjoint set. Okay, disjoint set. Okay, so what is actually meaning of a set? Okay, so let me consider for disjoint set, that means we need at least two sets. Okay, A and B, two sets. Okay, we are taking minimum two sets. Okay, and B two sets. I consider here A and B are two sets. Okay, so disjoint set means whenever you take their intersection, that means A intersection B. Okay, what is mean by disjoint set? Whenever their intersection gives the value only phi. Okay, that means we have only phi common between these two sets, we call it as the disjoint set. Okay, for example, mathematical way I'll explain. Okay, example first, A set I consider here 1 2 and set B consider here A B C. Okay, so you can see that there is no any element common between set A and set B. There is nothing common. Okay, only one element which is present in all the set, which is a phi. Okay, we know that the phi is a subset of every set, so phi it is present here, phi it is present here. So we this implies we write A intersection B as a phi. Okay, A and B, their intersection is a phi. I hope guys you all have understood. Okay, what is meaning of a disjoint set? Okay, disjoint set means the intersection between two sets, whenever it is a phi, we call it as the disjoint set. Okay, after disjoint set we go for the complement of the set. Okay, okay, next point we continue with the complement of the set. So we have next point, very important point here, complement of sets. Okay, complement of the set. Okay, what actually the complement? That means the element which is outside from the given set. Okay, that one is the complement. Okay, let me write in simple word, the element which is outsider from given set. The element which is outsider from given set, okay, called as a complement of the set. Okay, and we denote in a set A. If we consider set A and their complement, we write A complement like this way, or a complement like this way. Okay, this one way this is the way we denote the complement of the set. Okay, the element which is from outside of the given set, okay, as the complement of the set. Yes, so and in mathematical way we denote a complement as, okay, in mathematical way we denote a complement as x such that x is outside, x does not belongs to set A. Okay, this is the complement of a given set. Okay, yes, so let me draw one of the diagram, guys. So Venn diagram, so that you can easily understand the meaning of a complement of the set. Okay, yes, if I consider set A here, this one is the set A. Okay, so complement of a set A means all the element which is outside from this set A. Okay, but not in a set A, and which is present in a universal set. Okay, see that these are the outsider element from our given set. This one is the our given union of a set, complement of a set. Okay, this one is the A complement. Okay, this one is the A complement, or we write this one as the A complement like this. Okay, yes, this one is the complement of the set A. Okay, by using Venn diagram, guys, we have represented here complement of the set. Okay, in mathematical way, let me explain with one of the example. So here, guys, I have taken one of the example. Okay, set A as a set of even number, and universal set I consider as the real number. Okay, and we know that all set of even number and odd number are subset of a real number. Okay, there we don't have any other numbers, okay, other than this. Okay, so mostly we consider set of odd numbers and set of even numbers. Okay, so that means we are taking universal set real number, okay, which is the part of even number or odd number. Okay, the number which is divisible by 2 we call it as the even, other than remaining number we write it as the odd number. Okay, yes, that means in a set A we have all the even number, then in A complement we have all the odd number only present. Okay, set of all numbers. Okay, set of all odd numbers. Okay, I hope you all have understood, guys. Okay, complement, what is the actually the complement is. Yes, so let me write some of the properties for the complement of the set. Okay, these are helpful for you all to understand. Okay, we are adding some properties. Properties for complement of the set. Okay, yes, so if you take complement of the universal set, okay, so U is the universal set. If you are taking complement, okay, complement of a universal set, okay, that means U complement. Okay, so we get the phi. Okay, that means there is no any element present. Okay, you get the U complement, universal complement set is a phi. Okay, yes, second property we are adding complement of a set of a complement number. Complement of a complement is only itself a set. Okay, that means a complement of a complement is a only. Okay, yes. Third property, a union a complement, that means set A, this one is a set A union with it's a complement, we get the universal set. Okay, we get the universal set. By Venn diagram you can easily visualize the figures. Okay, yes, again fourth we write here a intersection a complement. Okay, that means a and intersection of a complement is a phi. Okay, there is no any element common between them. Okay, a is a different and a complement outside than a. Okay, whenever we take their intersection we get the phi. Okay, okay, so fifth property, a union universal set. is only the universal set. Okay, so you can see that guys, A union universal set, obviously you will get the universal set only. Okay, and the sixth property we consider A intersection universal set. Okay, A and universal set, we want the intersection between them, so we will get only the common element which is in a set A only. Okay, so this is the set A. Okay, so I hope guys you all have understood what is actually the complement of the sets and their properties. Okay, so if you want, you can note it down, this property. We move to the next point. Okay, so that one we will take in our next lecture, guys. So that is enough for our today's lecture. Okay, up to the complement of the set. So if you have any doubt, difficulty, guys, let me know in my comment section. I will come up with the similar videos. So that's it for our today's lecture. Thank you everyone. Thank you for my today's lecture.